Hello dear students, this is your Jagan sir from Physics with Jagan sir YouTube channel, and we had successfully completed vectors chapter, and after that we had seen what is trajectory motion, and we wrote trajectory equation, and we have solved some numericals also on that, and after that we have seen what is distance and displacement, and after that speed and velocity and acceleration also we have completed successfully along with the some critical numericals, and after that we had successfully completed uniformly accelerated motion equations in horizontal direction in our last class, and today we are going to see the same uniformly accelerated motion equations in vertically vertical direction. We are going to see those uniformly accelerated motion equations, and here we know uniformly accelerated motion equations are v is equals to u plus at v square minus u square is equals to 2a s, then s is equals to ut plus half at square v square minus u square is equals to 2a s, s is equals to u plus v by 2 into t. These are the 5 uniformly accelerated motion equations we have seen in our last class in horizontal direction. Now, how these will vary when we are applying in vertical direction? This is what the question is. Now, see here, very important point. Let me discuss. In an example in our last class, we have seen an example. Suppose if an object starts its journey from here and reaches this location, and let it is v1 velocity, let it is v2 velocity, and v2 velocity is in case less than v1 velocity. This says that of course the direction of velocity will be in the direction of object motion, and here its velocity decreases means the object is getting retarding. The object is getting retarding means the acceleration is in the opposite direction of velocity, okay. Now here, when object is in the opposite direction, when the acceleration is in the opposite direction of the velocity, this says that its velocity is decreasing. The object velocity is decreasing. Am I right? Now see here, the next point is, here earth is present. Let us assume earth is present. An object is placed at this location. Suppose an object is placed at this location, and when this object is falling or starts its journey, that means let us assume it is, I am dropping an object. Immediately earth tries to pull that object with certain amount of acceleration. Whenever an object is, suppose it is an object, if I am leaving this object, earth immediately tries to pull the object towards its center. Earth is trying to pull the object towards its center with certain amount of acceleration. That acceleration is known as acceleration due to gravity. And see here, this acceleration due to gravity representing with the value g, which is generally we consider its value as 10 meter per second square. And here you must understand one point. Earth is always trying to pull the object towards its center means this vector acceleration is actually a vector. So this vector is always representing in the downward direction. That means in all the cases the acceleration due to gravity remains minus g meter per second square, right? Minus g meter per second square. Now let us see case 1, when object is throwing up with some velocity. if I am throwing an object with some velocity in the upward direction, how the uniformly accelerated motion equations will be varies, that we will see here. Now, first one is v is equals to u plus at. How this formula will changes. Suppose the case is saying that object I am throwing from here, and suppose it reaches here, and here initial velocity is u, here velocity attained by the object is v, and suppose this is the displacement traveled by the object from here to here, and let us assume time taken is t. Time taken to reach from here to here is t. And you must remember one small and a most important point. In any case, the point from where object starts its journey, that location we have to consider as origin. We have to consider as origin. Okay, right. Now this is our origin. This is our origin. Right. From origin, always upward direction we have to consider as positive, now downward direction as negative, rightward direction as positive, leftward direction as negative. Leftward direction as negative. Clear? Then next point. Here this formula will be, when object is at this point, it is velocity representing in the upward direction, because still it is moving in the upward direction. So v will be positive and u moving in the upward direction positive, but acceleration, this acceleration is due to gravity. Due to gravity, so it is representing in the downward direction. A value is equals to minus g into t. This is the first equation, how we can write this one. Then second equation, s is equals to ut plus half at square. That is, displacement is in the upward direction, so we have to consider as positive, right? And object initially having upward direction velocity ut plus half minus gt square, because acceleration due to gravity is always towards the center, that is minus g in the downward direction. So s is equals to ut minus half gt square, minus half gt square. Then third one, v square minus u square is equals to 2as. V square minus u square is equals to 2as. Then at this location velocity is v square, and initial velocity is u square, then u minus g, 2 into minus g, then this displacement is also in the upward direction for the object, positive, yes. So v square is equals to u square plus 2g, sorry, minus 2g, yes. Clear? These three are the most important formulas, so we can stop here. And the next point is case 2, when object drops from certain height. When object is dropping from certain height. And remember, in the question, if they are representing an object is dropping or object is from start, right? If from rest, starts from the rest, if these are the words, then you must remember u value remains 0. In such a case, u value remains 0, right? Now the condition is the object is having initially at certain height, yes. Otherwise, to avoid confusion, let us see one thing, we can keep it as h. Now the object is starts its journey from this point, so I have to consider this point as origin. I have to consider this point as origin, right? And downward direction I consider as negative, right? Negative. And initially the object starts from rest, because I am dropping the object. Dropping the object says that initial velocity is equals to 0, and when the object reaches this location, its velocity is v. Its velocity is v. Let us assume its velocity is v. Now here, how can we write v is equals to u plus at formula? In this case, how can we write that? That is minus v is equals to origin. From here, initially I I am dropping means initial velocity becomes 0, that is 0 minus gt. So v is equals to gt. Now second formula, s is equals to ut plus half at square. How can we write this one? See here, the object starts its journey from here and reaching here, and it is moving in the downward direction, means the displacement will be negative, right? Of course it is the initial location, this is the final location, and the displacement is in the downward direction, means, and from origin downward direction we are considering as negative, so this will be minus h is equals to u value. Initially it is a rest position, right? As per the question, it is starts from the rest because it is dropped, plus half minus gt square. Then h is equals to half gt square. H is equals to half gt square. Then third one, see here, v square minus u square is equals to 2as. 2as. How can we write this one? See here, when the object is reaching this location, it is having a velocity in the downward direction, means this should be negative velocity. So I can write it as minus v whole square, right? And we are dropping the object, so its initial velocity becomes 0 square 2 minus g minus h. Then v square is equals to 2gh. So the formula will be turns into like this, right? And case 3, let us see the case 3. In this case, let us assume when object thrown in downward direction with some velocity, right? Now the case is when object is throwing with some initial velocity, right? And the point from where it starts its journey, we have to consider it as origin, and we are throwing in the downward direction. That means initially the velocity vector becomes minus u, and suppose it reaches this location, and here it will be minus v, and the displacement it traveled is h, and of course it will be minus h, because from origin point, from the point where it starts its journey, it is coming in the downward direction, so it will be minus h, right? Now how can we write v is equals to u plus at? This formula how can we write in such a case? See here, it is moving in the downward direction, and velocity vector at the end of the journey is in the downward, means minus v, right? And u value is equals to minus u and minus gt. So this becomes v is equals to u plus gt, right? Number 2, s is equals to ut plus half at square. Now the displacement is in the downward direction, minus h, right? Then u is in the downward direction, minus u t plus minus g t square. Clear? Then h is equals to ut plus half gt square, right? H is equals to ut plus half gt square. And third one, v square minus u square is equals to 2as. And here in the final position, its velocity becomes minus v square minus u, because initially it is moving in the downward direction, so we consider it negative sign, 2 minus g, and displacement is in the also downward direction, so minus h. So the formula turns to be v square minus u square is equals to 2gh. This is what the third case, right? And we have seen three different cases, and fourth case, case 4, if object thrown in upward direction with some velocity from top of a cliff or building, whatever that might be. Building, let us assume cliff or building. How the uniformly accelerated motion equations will vary, changes when we are throwing an object from the top of the cliff. That means this is the top of the cliff, this is the object, right? And here I am throwing this object in the downward direction and it is falling at this point. This is the case actually. See, here initially I am throwing the object in the upward direction. Sir, u value will be positive, and when it is reaches here, velocity will be negative, minus v, it will be minus v, right? Then the height of the building is h, and from the point where it starts its journey, we have to consider it as origin, as per our previous concept discussion also, origin. From origin to it is coming here, and we are considering this as the final location, right? Now initial location and final location, the separation, the shortest path between the initial location and final location is the displacement. So this is what the displacement, that displacement value s is equals to h here, right? Now initially object is at this point, finally at this point, so the displacement is in the downward direction, so I have to keep it as negative, right? I hope I am very clear. Now we will see how the uniformly accelerated motion equations will change according to this situation. Clear? Now first one is v is equals to u plus a t. Here v value will be minus v, upward direction, initial velocity is in the upward direction, so u, and acceleration due to gravity always towards the center of the earth, which is minus g t. This is what the representation. So if you want, you can also write it as v is equals to minus u plus gt, no problem. Clear? First condition. Then the second one is s is equals to ut plus half at square. How it will be changes? Now the displacement is in the downward direction, means minus h, u is in the upward direction, ut minus gt square, that is h is equals to minus ut, plus half gt square. This is how we can modify. Clear? And third formula, v square minus u square is equals to 2as, that is minus v square minus u square, and here I am keeping u as positive because initially object is moving in the upward direction, right? 2 minus g, and ultimate displacement of the object is in the downward direction, ultimate displacement, so it will be minus h. So v square minus u square is equals to 2gh. This is how we are representing in four different cases. How the uniformly accelerated motion equations can be applicable. This is what the case. Now based on this observations, let us try to solve some critical questions which will be very helpful for your upcoming entrance examinations. And along with the concept, we are going to discuss some important and hard problems here. Clear? And this will really helps you in scoring best in your examination. Now the first question is, see here, suppose consider two cases. Number one, A ball that has been thrown straight upward from the edge of a cliff. Let us assume, this is a cliff, and the initial speed of the ball is 20 meter per second. It is moving in the upward direction with the velocity of 20 meter per second. 20 meter per second. It goes up and then falls back down, eventually hitting the ground beneath the cliff. That means it is moving like this and falling here, hitting the ground. Right? In case B, let it is case A, let it is case A, let it is case B. Let it is case B. In case B, the ball has been thrown straight downward at the same initial speed. That means this is the cliff, and here it is throwing in the downward direction with the same velocity 20 meter per second, 20 meter per second, hitting the ground beneath the cliff, right, downward with the same initial speed. In the absence of air resistance, would the ball in case B strikes the ground with question 1, smaller speed than in case A, question 2, same speed as in case A, question 3, greater speed than the case in A, right? Chalo, let us first find what would be the velocity when this object is hitting the ground. What will be the velocity when it is hitting the ground? And cliff height is not given. Let us assume it is 10 meters. Let us assume it is 10 meters. Okay, right. Here in this question, you have to analyze one situation. There is a relation between initial velocity, and they are asking final velocity, and the separation, let us assume 10 meters. So out of the given equations of the uniformly accelerated motion equations in the vertical direction, which will be very suitable here, that we need to find first one. Now by using v square minus u square is equals to 2as, and here v square, which we are going to find, and u is 20, and the journey from where object starts its journey, the point from where object starts its journey, we have to consider it as origin. From origin, initial velocity vector is moving in the upward direction, so this will be in the upward direction, means positive 20 only. Then 2 into minus g, and s value, that is, this is the initial location, this is the final location. So I am assuming h value as minus 10, because this is the displacement traveled by the object, and this is the total distance traveled by the object. Displacement traveled by the object, right? So s is the displacement, that's why I am writing the s value. Clear? Then v square minus 400 is equals to 200, then v is equals to under root of 600 meter per second. This is the velocity attained by the object when reaches the ground. Similarly, in second case, let us see. Here also the given components remains the same: initial velocity, final velocity, and displacement. So again we use the same formula: v square u square 2as, and v value, which we are going to find, u value minus 20 square 2 minus 10, and it is displacement minus 10. Here, since a is equals to minus g, acceleration is due to gravity, right? Now v square is equals to 400, 200, v is equals to again under root of 600 meter per second. 600 meter per second. Clear? This is the one of the best question for your examination, right? And I hope you understood it very clearly. Let us go for the second question. And the first question is saying that the velocity attained by the object in both the cases remains same, right? This is the first question answer. And second question answer is, let us see. A cricket match customarily begins with a coin toss. That means here a toss is present. Let us assume a toss is present. The up, the umpire tosses the coin up with an initial speed of 5 meter per second. That is, this is 5 meter per second. In the absence of air resistance, there is no air is existing actually, air resistance. Question 1. How high does the coin go above the point of release? That means how high the coin will go above the point of release. This is the point of release. Okay. This is the point of release means we have to consider from there its journey starts, that would be acting as origin. That would be acting as origin. Right? From origin, it is moving in the upward direction, and they are asking how far does the object reaches. Automatically, velocity vector is in upward direction, acceleration due to gravity is in downward direction, right? Downward direction, that is velocity vector and acceleration vector in opposite direction to each other. This makes retardation in my object. That means as it moving in the upward direction, its velocity will be reduces to zero, reduces to zero, right? Reduces to zero. Now they are asking at what height its velocity becomes zero. This is what the question 1, right? Now again, initial velocity we know, final velocity we know, acceleration we know, and h value they are asking us to find. And out of the given equation, which will helps us very clearly, again by using v square minus u square 2a yes, by using this one, right? Now v square, that is 0 square minus 25 is equals to minus 10, and h value, see from here object is moving in the upward direction, so height will be considering positive. From origin to upward direction we are considering as positive, right? So I am considering it as positive. Then minus 25 minus 20 h is equals to minus minus get cancel 5 by 4 meter. H is equals to 5 by 4 meter, right? Then first question completed. Second question, what is the total time the coin is in the air before returning to its release point? That means it starts its journey here, reaches here, and again coming to its original position. Okay, now for whole journey, how much would be the time taken for the object? This is what they are asking. See, by using, for second question, by using v is equals to u plus at, because we know initial velocity, we know final velocity as 0, right? I am considering t1 time taken to reach from here to here, t2 time taken to reach from here to here. Okay, now for upward journey, right? Then 0, 5 minus acceleration is equals to minus 10, that is acceleration means acceleration due to gravity, minus 10 t, that is t is equals to 5 by 10, 1 by 2 second, 1 by 2 second. Now see very clearly, if it is taking in the absence of air resistance, for upward journey half second means, similarly for return journey also half second. So total time is equals to t1 plus t2, that is half plus half, which is equals to 1 second. In 1 second the object reaches from bottom to topmost point and again comes to original location. This is what is time taken. So 1 second is the answer for second question. Clear? Then let us see the third question. Third question. A particle is projected up with the initial speed of u is equals to 10 meter per second from the top of a building. See, it is a building. From top of the building, it is throwing with the initial speed of 10 meter per second, 10 meter per second at a time t is equals to 0. and after at a time 5 seconds the particle strikes the ground. That means it takes 5 seconds to reach ground. 5 seconds to reach the ground, right? The particle strikes the ground. Find the height of the building. They are asking us to find this height, how much it would be. Again, here the point from where its journey starts, that we can consider as origin, and this is final location. So the separation between initial location and final location is the displacement, and the displacement value is here h, but it should be minus h, because from origin to final location is in the downward direction, so we have to consider it as minus h, right? And time taken is 5 seconds, and they are asking us to find h value, and there is a relation which tells displacement, initial velocity, time taken. That relation is by using s is equals to ut plus half at square, right? Now s is downwards, ultimately the object is reaching finally at this location, so we have to consider only displacement. So minus h, initially moving in the upward direction 10, time taken is 5 plus half, acceleration means acceleration due to gravity of the earth minus 10, time is 5 square. Clear, right? Then minus h is equals to 50 minus 5 into 25. Then minus h is equals to 50 minus 125, h is equals to 75 meters. H is equals to 75 meters. And see here, we are successfully completing the concept. Along with the concept, I am giving numericals for improve your understanding levels of the subject. This will really helps you a lot in your cracking entrance examinations. And if you have any queries, you can message me or you can comment me in our YouTube channel. And the next most important point is, for materials you can follow us, right? And this will be the end of the today class, and we will continue next topic in our next class. Have a great day. Take care. Bye bye.